Welcome to Pavithra Laptop Care. So 2 days ago, a subscriber has requested to tell me that about a charging IC section, but the thing is I couldn't help him properly because there was a festival, so I was on leave. So now I am in office. So just I wanted to explain him what was the issue and what may be the issue, because he has a issue with charging the battery. When he connect both battery and adapter, the laptop was going to switch off. Okay, he has sent a schematic. So using that schematic, I wanted to explain. He is from Ecuador. Ecuador, maybe it's a South America country, I think so. But anyway, to him this video is dedicated. He has sent a charging IC. That one is ISL 95522. His laptop is Dell 5584, I think so. Okay, so based on his charging IC, I will explain one by one. First, before doing any service, first we need to understand what is that IC and what it does, how battery will charge. Okay, this is charging IC which you sent. That one is 95522 ISL. Okay, in this charging IC, what are the pin and what are the pin connection and what it does, everything I will explain. Please note down one by one. Okay, I will come from pin number 1 to 32. It has pin total 33. One is internal ground and the remaining outside pin you can able to see. So one is 1 and 2. See here, 1 is negative side, it's a battery CLR negative part, and this one is battery CLR positive part. This is a sense pins. Okay, it will sense the battery side CLR. So negative side and this is the positive side. This is sense pin. And V system is a feedback pin. V system is a feedback pin from the buck converter. Okay, this is a feedback pin. Here it's a boot to U gate 2, phase 2, L gate 2 and VDDP. See here it's a 2, it has mentioned. Here actually this IC contains two phase. Okay, 2 kind of means it's a total 4 switching circuits it has. So because of that it has mentioned it's a 2. This is second side switching circuit will be there. No, for that it's a boot voltage. I mean boot, it's a driver. In older ICs there was a driver to boost the gate circuits. Okay, the particular circuit, it's a phase, high gate, high level gates will be there. No, for it the phase, for this phase it's a boot driver. See, previously we were using high low MOSFET, even nowadays is there. Okay, here is the gate and here is the gate. Okay, here a particular driver IC will be there. IC, this is called driver IC. Here also a driver IC. Okay, this is called a boot. This is called boot 2. Okay, this is a driver IC supply. And here upper gate and lower gate. See here these two MOSFETs are there, right? This is a upper gate, this one is upper gate, and here it's a lower gate. This is the gate voltage. This particular pin is connected, upper gate is connected to this higher MOSFET gate and lower gate is connected to lower gate MOSFET. Here phase is the output in between these switching circuits. And here is the VDDP. VDD is a supply to this particular driver, that boot 2 and boot 1. That supply IC which I told, no, for that it's a input voltage. VDDP is a supply voltage for boot and this boot. This boot is very important. This driver is connected through a capacitor and a resistor and connected to the phase. Okay, here its internal diode will be there. Through that diode, the supply voltage will start. That phase, what is that? High-low MOSFETs will generate that. What is that switching process? No, for that pulse it will generate through that internal diode, boot 2 and boot 1. See here, negative side, it's a positive side, sensing resistors. What it will be there? No, that it's a sense. The sense will accept from these two pins. This one is feedback pin. This one is boot driver, that which I told you. No, this is the driver for high MOSFET. It's high MOSFET will be there. No, that phase. And here is the phase. Phase, you know, the output of these switching circuits. This is the low gate second switching circuits, low gate supply, that pulse. And this is the voltage for this driver, this boot 2 driver and boot 1 driver, internal LDO voltage. So pin 1, 2, 3, 4, 5, 6, 7, 8. This one is over. Like that same thing, low gate, phase, upper gate, boot. See, these all are second phase. I mean, one more phase I told you. No, there are two phase here. It's a one more switching circuit is there. For that, there is a first switching circuits, low gate voltage, high gate voltage. I mean, it's a pulse. Okay, it's a phase. Phase is the output of these switching circuits. Here's the boot, the driver, which I told you. No, it generates the pulse. For this, it's a input. For this, it's a input voltage. This is VDDP. AAS gate is optional. It's for a supply gate supply for P channel MOSFET. Okay, in some cases they will be using the P channel MOSFETs, but here it's not used, so it's not necessary. Okay, once you connect the adapter, then if it is more than 3.2 volts, then this phase will active, this gate will active. Okay, see here, CS in, CSP. Okay, N is the negative side and P is the positive side of the adapter side CLR. Adapter side CLR sensor. Okay, pin number 13 and 14 is the sensor. And 14 and 15. Here is the adapter sensor. When you connect the adapter, that sensor will connect to the pin number 16. It means adapter is connected or not, that sense will happen here. And here is the DC in, this particular IC input, okay, which is come from DC in or output of the CLR voltage. Mainly the type C output you will get it here. Okay, see here one more pin is there, that's called, it's a VDD. What is that VDD? This one is internally adapter and analog and digital circuits will be there. For that, it's a supply. It gives the biased supply. This one is main IC inputs. This one is internal LDO supply will be there. That one it will produce analog and digital circuits will be there for that supply. AC in, the adapter which is connected, this adapter, that indicator, that is sensor of this adapter is connected or not. And C min is the OTG enable pin. This one is OTG, one option will be there, that OTG pin enable. Here SDA and SCL, it's a very important thing. SDA and SCL, it's a data communication path, and this one is clock. Okay, this should be there to communicate with the battery. If this two not there, then there will be no use of voltage. Here usually voltage 3.2 or 3.3 voltage will be there to carry the data and to carry the clock. Okay, here processor hot, here it's a sensor, it's a current sensing resistor will be there. I mean, through that this pin, the processor is hot or not, that indication comes to the charging IC. If it is a low, then it will be off condition. Okay, AC OK is the drain output thing. Here through this AC OK pin, this through this AC OK pin, the IO will consider the adapter is connected or not. Okay, it's a valid input will be there, no, AC OK. Using this AC OK signal, the IO which the embedded controller will be there, no, that controller can understand the adapter is connected or not. Okay, next it's a battery gun. What is that battery gun? No, it's actually battery present or not, that indication pin. Okay, if it is a high, the battery is absent. If it is a low, the battery is connected. Okay, CM out, the OTG which I told you, no, that is enable pin. This one is output of OTG. This is not required. And here program is there. See this program in the sense internally what kind of cells battery it has connected, single cell, double cell, 3 cells, and the frequency of this particular what is that battery, the frequency, it communication between this battery and this charging IC will be there, no, the frequency is must and should. This one carry to this SDA and ACL. This particular frequency, how much will be there, that one it examines. Usually 733 kilohertz to 1 megahertz frequency will be there, that one it will monitor, and current also it will monitor. Internal comparator will be there, that error message it gives. If any error in comparator, that message it will gives that information. And this one pin number 29, AM on and BM on. What is that AM on? This is the adapter monitor. BM on means it's a battery monitor, means its adapter current is correct or not, that monitor will happen through this particular pin, and the current of battery is good or not, that pin, I mean using this pin will be monitored. Okay, PCs, what is this PCs? See here, it has gone to where it's a power system. Actually internally what are the components, power will be there, that power indication will happen through this PCs. Okay, wattage information as goes to this particular internal pin. VBAT, VBAT, what is that VBAT? C31 is connected to where this one is battery section, means what are the battery voltage will be there, that particular voltage monitoring pin, the battery voltage monitoring pin, VBAT. Okay, what are the exact voltage will be there according to this, what I explained, according to this you need to check, okay. The B gate, what is this B gate? Here is a P channel MOSFET will be there, which is connected to the battery side, that gate voltage supply pin. Okay, so that's it. Here is the pin explanation is over. Okay, so according to this what I explained, it's good or not, monitoring pins are good or not, depends on voltage, you have to check in your laptop. Okay, this one adapter pin to sense the adapter voltage. Here is the battery pin, I mean it's the input voltage of IC. Okay, here is the CLR sense input and output, and here is the battery sense input and output. Here is the phase 2 and phase 1. Here what is the total 4 switching circuits will be there. One high-low MOSFET switching circuits controller here, I mean low gate and high gate and phase, and here it's a second switching circuit will be there, no, for that low gate and higher gate, and boot 2 and boot 1 is the driver for gate voltages. Okay, phase is the output of this particular switching circuits. You got my point, right? So now we will come one by one, and one more doubt is there. So what is that? Here it's a battery CLR, what voltage will be there? That is a major doubt, and it's a latest laptop you come to know what the voltage will be there in battery CLR. See, I'll explain you clearly, so you need to understand. See, in your circuit the IC is 95522. Wherever the dy is given, this particular component won't be there if this particular IC is there. Okay, as per your IC, I will explain this. See here, this CLR, input CLR SDC in is a type C pin input voltage. Okay, through this CLR, the output the named as 20 volts underscore DC bat. Okay, this CLR output means it's a 20 volts is coming through this CLR and going to this particular high MOSFET. Okay, here is a high MOSFET, that switching circuit 1, high low MOSFET switching circuit 1 is there, no, that this is the phase 1. See, this phase 1, this one is high MOSFET input, this CLR. So I'll come to the CLR 2, depending on that one minute, just a minute. See here, up to here this 20 volts has come, and this one is connected, it's commence from here to here, and this gap will be there, that gap having 19 volts, and again it's commence to this one. Okay, here is a DC bat, see DC bat, here it has come, and here the supply, the 19 voltage supply has given to the second phase switching circuit, okay, DC bat. Here is the 19 volts, and same 19 volts where it has come, here is the point, and here one more MOSFET is there. What is that? PU4413. Here is the P channel MOSFET. Okay, P channel MOSFET, one side 1 2 3 input, and this one is gate. The P channel already explained, one pin has gone to P channel gate, last one P gate I think so, that supply is here. Through this capacitor it has divided, and here gap will be there. See, PG4415, this gap won't be there in ISL 95522. See, its dy has given, dy in the sense this gap should not be there. Please note down, this gap should not be there. This 19 voltage has come here, and here it will get stopped, and if this gap is connected, this 19 voltage will commence through here and it will goes to here. What is this? This point, here is the phase. See, phase output also connected to the 19 voltage, phase 1 and phase 2. Both output through this coil has connected to this 19 volts path. If it is connected, 19 voltage and this phase voltage will be the same. It means it gone to second CLR. See, second CLR. This one is one more P channel MOSFET, which is connected to the battery. See, battery is a P channel. Here is the battery voltage, BT plus is the battery voltage. It has connected to the drain of this P channel, and P, it's a source. See, source is connected to this 19 voltage. Means this is the second CLR. This is the battery CLR. This battery CLR having 19 volts. Okay. In some schematics, it has 19 volts. In the both CLR having 19 volts. This is clear. Okay. See here, this what is that? Here actually in this particular IC doesn't have this switching circuit 2. Okay, switching circuit 1 is there now. This output is connected to the coil PL4401, and this coil output is connected to the 19 volts. See, 19 volts. It has come to here. If jumper is connected here, this same 19 voltage has gone to CLR voltage. I mean CLR. Here is a P channel MOSFET. According to the switching circuit, this particular CLR voltage connects to the, what is that, 19 volts path. In case of adapter is absent, this particular voltage is connected to here. Okay, that's it. Any doubt in this? See, one more thing is there here. Here is the feedback. I have seen a difference here. See, N gate over, and here is the jumper. See, in this particular IC, this point also you need to check. PR4480 it should not be connected. It's a DY, it should not be connected. What pin it is? This one is V6. This feedback is not connected here. Okay, these all pin connections should be okay, then only your battery will charge. Your battery will charge. If you have any problems related to the battery, when battery is connected to the particular connector and it's switching off, right, that's a problem you are getting. So that may be the because of this particular MOSFET. See, here is the P channel MOSFET is there. You need to check this according to the gate voltage. All supplies are good or not according to this connection, you need to check. And second thing, what I told, it's 95522 has DY. This jumper should not be there. And the next one, this switching circuit. Here the second switching circuit is not there because here DY has given. Okay, DY has, these two won't be there, and this coil output should be these switching circuits. Here is the phase of 1. See, switching circuits 1 output should be there. According to gate voltage, the voltage will generate here, but the one thing is it has connected to 19 voltage path. In case if it is joined, this gap is joined. Okay, these all conditions should be good, then only your battery will charge. Okay, this also, this MOSFET also you need to take care. Here what is the gate depends on that this particular voltage will pass or not. It depends on this gate voltage. And here gap also is there. For your IC, gap should be there. Then see, gap should be there in the sense there is no use of this MOSFET. Here it's a DY has given, so here this MOSFET won't be there. Okay, here directly the battery voltage coming to this particular CLR. The CLR having 19 volts. See, this is the first time I am seeing here. I mean, I already seen, but this is the first time everyone knows here. The CLR having 19 volts, the battery CLR having 19 volts. This is very, very important point, has to be noted down. Okay, that's it. If any questions, you can contact as usual through WhatsApp. Definitely I will reply to your questions. Okay, sorry for yesterday. So yesterday I didn't attend properly because I didn't have my personal laptop at home. Okay, that's it. Okay, one more thing. If anybody wants to join our PLC, WhatsApp number +918861880678. And thank you very much.